Hello, coming to you from home this evening. I thought I would just kind of revisit this thing called ATP for a minute. When we left the mountainside, we talked about the amount of ATP in the heart at any one time, and that's kind of critical for you to understand. In that, if there are only 700 milligrams of ATP in the heart at any one time, and given 10 seconds at 60 beats a minute, you've got about 10 seconds of work of energy in the heart. So then begin to talk about energy turnover. And the critical aspect of this whole thing is if you don't have the right component parts to build ATP and the mechanism to get them into the mitochondrial wall and into the combustion chamber where all of this takes place. And it is so incredible. This turnover is phenomenally fast. And there is enormous amount of toxicity that's created all in this one procedure. So obviously we have to have all of the mechanisms in line and ready to capture this free radical activity or it does damage. Now, the long and short of this thing is at 2,500, catch this, 2,500 calories a day produces 400 pounds of ATP. You want to talk about an efficiency of a body. It has got to be that. But the minute you short circuit that, the minute you go to stimulants and you fail to create this, and you begin to use sugar and caffeine and stimulants along those lines, the mayhem that you create in the body is literally immeasurable. So here we have now all of science looking at some very unusual language, such as metabolic syndrome X. So I want you to picture in your mind, if you know, and this again is interesting science, and if a 170-pound man only has room for about 7 grams of glucose, sugar, in the blood at any one time, and he begins to use sugar as a stimulant, and this refined sugar that we're taking into our body has a couple of things in common, and it's just about a 50-50 split. When that stuff hits the digestive tract, it's parsed into two distinctive forms of sugar. One is glucose and one is fructose. Now the fructose, if we're not going to get it into the blood and into usability, the body looks at it and says, guys, we got to be storing this thing because we're looking at a time when we won't have this energy. So that cycles through the liver and it comes back in the form of triglycerides, and then it's stashed around the belly. Now, isn't that interesting? Because now we have this belly fat that everybody's dealing with, along with, forget that, how about the visceral fat that coats the inside organs? So you've got that to contend with, but the body understands that the highest amount of ATP produced is literally from fat, not carbohydrates and not proteins. So it's storing it for future use, much like bears do. Now, the other side of this gets really pretty interesting and pretty nasty. Because as we look at it, this other half of that sugar molecule travels through the pancreas activity in the insulin area. And once maybe we have a lot of sensitivity, maybe we just have fatigue in the receptor sites where insulin is used to take sugar into the cell. Whatever the case, that sugar that is not being used passes on, and it creates one of the most devastating of all areas of science called amyloid beta plaque. It's called AGEs, advanced glycation end products. Now, this begins to get really problematic because it begins to coat the arteries, the capillaries, with plaque. That's the first part. The other side of it, which is an amazing word in science, but it creates tangles in the nervous system. So all at once you have just created a mess for your body to deal with, in that your body has transferred the usage of sugar, immediate energy, short term, which by the way shrinks the brain. So we have created kind of a dinosaur-like effect because the brain shrinks and the body gets bigger. Isn't that a depiction of a dinosaur? And we have a nation where we are considerably overweight. So this whole thing about making the nervous system work in an environment that's kind of like walking around in molasses, so all of that, the signals that go back and forth into the brain and making the organs of the body function better and faster are clogged up. Then you've clogged up the whole of the artery system, so you move blood slower, and in many cases, such as in the brain, you don't get the blood into the brain, therefore the oxygen is not getting into the brain. So lo and behold, you have that capillary activity. If you do not get oxygen to the cell, it dies. So are we not functioning today in a world of dementia? People are really concerned about dementia. They're losing their memories. And we see that all of the time. Plus we're getting bigger. And then you begin to introduce all of the diseases that surround this thing called the energy that's created from sugar, the metabolic syndrome X, the periphery of cardiovascular issues, the issue of diabetes, cancer. You can go all around the line, and all of these things are directly related to what you're using to form sugar as an energy rather than making energy the way the body likes to, which is through ATP. We've covered a lot. I'll let you go with this, and we're going to go into all of this stuff as we function. So join me in this desire to make the body healthy and make it more functional. Thank you again, and shalom from Colorado.